So hello everybody, today we're going to be doing a nice little linear algebra problem. Namely, we're going to be dealing with vectors and vector products today. So the problem states that we should find the number m such that the vector a cross product b cross product c is perpendicular to the vector b minus c if it is given that a is equal to m minus 1, 1, m plus 1, b is equal to 2, 3, and 1, and c is equal to 1, 3, and 2. Then we're supposed to find the surface area of the parallelepiped constructed over the vectors a, b, and c. Okay, so we all know about the rules of vectors. For example, if we're given the dot product of two vectors, that is the same as the modulus of vector A times the modulus of vector B times the cosine of the angle between vectors A and B. Okay? So, in order for two vectors to be perpendicular to each other, this dot product must be equal to 0. Okay? And since we're dealing with non-zero intensity vectors, this means that the cosine of this angle must be 0. Okay, so from here we get that a times b must be equal to 0. Okay, so now when we've got that covered, I'm just going to go ahead and first we have to compute the vector, the following vector, a cross product b cross product c. Now, how do we compute this? Well, first of all, we're supposed to find the cross product of vectors a and b. Okay? So that's the same as the matrix of I, j, and k, which are, of course, the unit vectors in the directions of x, y, and z axes. Then we'll just put in the coordinates of our vectors a and b. So here we're going to have m minus 1, 1, and m plus 1. And in the bottom row, we're going to have 2, 3, and 1. Now, by using, and of course, this is a determinant, and we're going to be using a third order determinant. So I'm going to be using the Sarce's rule, m minus 1, 1, 2, and 3. So we just rewrite the first two columns, and then we cross multiply. Okay, so here we have, okay, first cross multiplication, second cross multiplication, third, and then we go in the opposite direction. Okay, so I times 1, that's simply I, 2m plus 2j plus 2m plus 2 times j plus 3m minus 3 times k minus 2k minus 3m plus 3I and minus m minus 1 times j. Okay, now let's just rearrange this in a slightly better form, in a slightly more structured form. As always, I'm going to use colors. So we've got I here, we've got I here as well. Here we've got j, another j, and here we've got two k's right next to each other. Okay, so when we factor the i's, we'll get 1 minus 3m minus 3. So we'll get minus 3m minus 2I plus 2m plus 2j minus m plus 1. We'll just get minus m, which is just m, and plus 1 plus m plus 3j. And for the third one, we'll get 3m minus 5k. Okay, now, so that's our cross product of vectors a and b. So a times b, cross product of course, is equal to minus 3m minus 2, m plus 3, and 3m minus 5. Now, what we want to calculate next is the vector of the cross product of a and b, cross product c. And we'll go ahead and do something very similar. So I, j, and k minus 3m minus 2, m plus 3, 3m minus 5, and finally c, which is 1, 3, and 2. Again, I'm going to use the Sarah's rule. I minus 3m minus 2, 1, j, m plus 3, and 3. Okay, so that will give us 2m plus 6 times I plus 3m minus 5 times j minus 9m plus 6 times k minus m plus 3 times k minus right here, okay, minus 3 times 9m minus 15 times I minus 9m minus 15 times I, okay? And minus 6m minus 4 times j. Okay, as in the first example, we're going to rearrange these terms a bit. Okay, so I right here, I right here, j right here and here, and k right here. Okay, so 2m plus 6, okay, minus 9m minus 6, minus m plus 3, minus 3 times 3m minus 5, minus okay, so 2m minus 9m is minus 7m. 6 plus 15 is equal to 21. I now for the j, 3m plus 6m is 9m minus 5 plus 4 is negative 1 times j. And finally, we've got the k, minus 9m minus m is minus 10m, minus 6 minus 3 is equal to minus 9k. So in other words, our vector of A cross product B cross product C has the coordinates of minus 7m plus 21, 9m minus 1, and minus 10m minus 9. Okay, so this is the first part. Now we also have to calculate the vector b minus c, which is exactly the same as subtracting their coordinates. So when we look at the coordinates of vectors b and c, we can see that the vectors, that this vector b minus c is going to be 2 minus 1, 3 minus 3, and 1 minus 2, which is exactly the same as 1, 0, negative 1. So this is going to be another part, another step in finding our solution. And then we said that these two vectors must be perpendicular to each other. So we're just going to go ahead and multiply their coordinates. So when multiplying their coordinates, since the unit vectors I, j, and k are perpendicular to each other, their dot products will always be equal to 0. So it's enough to say that we'll just multiply the same ones, okay? So the first one with the first one, the second one with the second one, and the third one with the third one. And then we can just go ahead and add those up. Okay? and set that all as equal to 0. So A times B, of course cross product, and that times dot product, this time B minus C, is equal to 0. Therefore, we get that minus 7m plus 21. 9m minus 1 times 0 is still 0, plus 10m plus 9 plus 10m plus 9 is equal to 0. Okay, so minus 7m plus 10m is equal to 3m. 21 plus 9 is 30, and we'll just put it on the right hand side, is equal to negative 30. And from here it follows that m must be equal to negative 10. Okay, so that's the first part of our solution. So now when we know about now that we know about the value of m, we can rewrite all of our original vectors. So A is equal to m minus 1, which is minus 11, 1, and m plus 1, which is minus 9. B is equal to 2, 3, and 1, and C is equal to 1, 3, and 2. Okay, now that we know about this, we're going to have to go ahead and find the surface area of the parallelepiped. So we're going to be using the cross product again. Why? Because the intensity of the cross product, I'll try and make a sketch right here. Okay, a little more to the left. So if we have vectors A and B, the cross product of these two vectors is going to be a vector that's perpendicular to both of them, and it's called A cross product B. And the length or the intensity of this vector A cross product B is equal to the surface area between of this parallelogram, which is formed right here. Okay, so let's first draw a parallelepiped. So it's not really up to scale, it's not really accurate, but it gives you the idea. So if these are our vectors, let's say this is vector C, this is vector A, and this is vector B, then we can see from here that the surface area of this parallelepiped is going to be 2 times the intensity of A times B okay, plus the intensity of B times C plus the intensity of A times C. Okay, so now let's go ahead and calculate these values. So A times B is equal to I J K minus 11, 1 minus 9, minus 11, 1 minus 9, and 2, 3, 1. Okay, so same story right here, minus 11, 1, 2, 3. So this is going to be I minus 18 J minus 33 K plus 2K, whoops, sorry, minus 2K. Minus 2K plus 27I plus 27I and plus 11J, which is the same as 21I minus 18 plus 11 minus 7J minus 33 minus 35K. Okay, now as for the intensity of this vector, its intensity is going to be equal to the square root of 28 squared plus minus 7 squared plus minus 35 squared, which is the same as, I'm just going to calculate it very quickly. So the square root of 28 squared plus 49 plus 35 squared which is the same as the 7 times the square root of 42. Okay, now let's just go ahead and do the other two ones. So B times C is equal to I J K 2 3 1 1 3 2 2 3 1 1 3 2 I J 2 3 1 3, which is equal to 6I plus J plus 6K minus 3K minus 3i minus 4j, which is equal to 3i minus 3j plus 3k, and its intensity is going to be equal to the square root of 3 squared, 9 plus 9 plus 9, which is the same as the square root of 27, which is the same as 3 times the square root of 3. And finally, let's do the final vector, a times c, I, j, k, minus 11, 1, minus 1, 9, minus 11, 1, minus 9, and 2, 3, 1. 2, 3, 1, I, j, minus 11, 1, 2, and 3. Okay. C is actually equal to 132, sorry. Okay. So we're going to get 2i minus 9j minus 33k minus k plus 27i plus 22j, which is equal to 2i 29i minus 9j 22 minus 9, 22 minus 9, which is equal to 13, plus 13j minus 34k, and the intensity of A times C is equal to the square root of 29 squared plus 13 squared plus minus 34 squared, which I'm going to compute. So 29 squared plus 13 squared plus 32 squared, which is the same as 19 times the square root of 6. So our surface area is going to be 2 times 7 roots of 42 plus 3 roots of 3 plus 19 square roots of 6. Okay, and of course, once we do some grouping, So 2 times 7 square roots of 42 plus 3 root 3 plus 19 root 6 will give us exactly 14 roots of 42 plus 6 roots of 3 plus 19 roots of 6, and that is the exact answer. But you can also put in that that's approximately equal to 194.2 units of measure, UOM. Okay, so that's just a side note. So if you enjoyed this video, make sure to leave a thumbs up and subscribe. I'll see you in the next one, and